doing a review today. So today we're going to, I was actually mostly planning on covering functions again, all right? But we're going to do a quick review of looping first. And then I have a challenge at the end if we have time for Shiny, which we may or may not, we'll see, probably not. But if not, you can try that on your own if you have time and you want to come back and do some stuff. Probably don't have time now, but maybe after the term is over or whatever. Okay, so quick review on looping. So let's say that you wanted to scale, which is going to be like z-scoring or standardizing, so it has a mean of 0 and a standard deviation of 1, every column in a data frame that is numeric. Okay, so we have the Palmer penguins data set, which looks like this. And what we're going to go ahead and start out with is having you try this first. Okay, so go ahead and get R launched. Type in library Palmer penguins and then penguins. And what I'd like you to do is apply this function scale to every column that's numeric. So this one, but not these ones, okay? Because those are not numeric, all right? So try to do that first through a for loop. And then as you do that, then I will, I'll show you my version of doing that after you give it a try. Okay? 2 minutes, give that a try. Okay, so in this case, this is actually harder than it looks. And the reason is because we're working with a tibble. Okay, so this is one approach. This is basically how I wrote it to start, but it didn't work. And I wasn't sure why, and then I figured it out afterwards. So here I'm just creating a new object called penguins2, which I'm going to redefine, okay, rather than writing over penguins. And then I'm going to say for I in seek along penguins2. Okay, so seek along is just going to be an index then from 1 to the length of penguins2. The length is going to be equal to the number of columns because a data frame is a list, right? And so it's just a list, and the length of the list is the number of columns where every element of the list is a new column. Okay, so this is going to go 1, 2, 3, 4, 5, 6, 7, or however many columns we have. Then I'm saying, okay, if is.numeric penguins2 I, then do this part. But this is the tricky part. We have to say drop equals true, okay? Because with tibbles, when you index them like this, penguins2, and then let's just say I closed it off there and I said 3 or 4 or 5, it's going to actually give me the data frame in return, okay? And so if I'm testing if that's numeric, it's going to be false every single time because it's a data frame, it's not a numeric. So it's a data frame rather than a numeric atomic vector. Okay, so then you have to say drop equals true to get it to drop the data frame attribute and just return the variable, just return the column contents. Okay, so that's a little bit tricky, but it's also sort of a good example in terms of review because that goes back to one of the very first lectures we had when we were talking about variable types and why these things are all so important. Okay, so by default, just as a reminder, by default, tibbles will not drop the attribute like this, okay? Whereas data frames, standard data frames will, okay? So had we have said as.data.frame on penguins, then we wouldn't have had to have this drop equals true, okay? Most of the time, in my experience, it's better to have drop equals false. It's better to return the data frame rather than just the numeric column. Okay, so I think that's a good default, but it does make things maybe a little bit more tricky in cases like this. Okay, and the reason I think this is a good default is because often when you're doing loops, you're returning in one iteration, you might return 3 columns. In a different iteration, you might return 2 columns. And then in a different iteration, you might return 1 column. Well, if you're using a standard data frame, it's going to be data frame, and then all of a sudden an atomic vector, right? Whereas a tibble would be data frame, data frame, data frame. Okay. So then within here, within this if, we're just saying penguins to I, so for the ith column, which we know is numeric now because of this condition, just scale that ith column. Okay, so we're actually redefining that column as the scaled version of it. Okay, and so then it ends up looking like this. So you can see they're all centered around 0. Okay, so let's try that again, but this time with lapply, and I'll give you a hint. In this case, we're not going to have to worry about the drop equals true or drop equals false, okay? Because lapply is going to always give you just the column back by default. Okay, so see if you can replicate that same thing now with lapply, and you might want to define a penguins 3 or whatever so that you don't overwrite that thing. You might not have to either though. Okay. Here is one way of doing it. I actually defined this thing as penguins 3, but then I didn't even need to because I didn't actually end up redefining it. So I'm wrapping this whole thing in data frame because lapply is always going to return a list. So if I just wrap that list in data.frame, it's going to return a data frame then instead of a list. I could have also used Tibble and that would have worked. But I think the names might change a little bit with Tibble. I don't know. I can't remember. So I'm going to use lapply on penguins 3. And then I'm going to apply this function x. So this is an example of an anonymous function, right? This function that I'm applying is existing within this loop and never again. Okay. Then I'm saying if is.numeric x, then redefine x so it's the scaled version of x, and then return x for each iteration. Okay, so x becomes a placeholder for the specific column. So we're going to have species, and it's going to first check if species is numeric. If it's not, it's just going to return x. It's going to return species as it is. If it is numeric, then it's going to scale it. Okay, and then it returns the scaled version of that. That makes sense? All right. Moving on to per very quickly. I'm not going to have you actually do this thing, but I just want to talk about this for a second. When do we use the tilde? Okay, so remember per map is exactly the same as lapply, except it has that shortcut syntax. Okay, and then there's all these variants of per that we use a lot, right? But per map itself is exactly like lapply, except it has this shortcut syntax. Okay, so the tilde is really just, you can think of it as typing function.x. Okay, that's exactly what it is. So if you had used lapply and did function.x, then it's exactly the same as map. Okay, so here's two examples of doing the same thing with per, but these are both equivalent. Okay, here I have penguins that I'm looping through. Notice I'm applying map.df because after I'm finished with the looping, I want it to return a data frame. And I'm just using the tilde here. And then the rest of this code is exactly like lapply, except I have .x instead of x. Okay, and on this side, I have the exact same thing, but I've put function x, function.x, rather than the tilde. And the reason they use .x instead of x is just to sort of distinguish it from your own functions, because anonymous functions, the way that we write them, we almost always write function x or maybe function xy or whatever. And so the dot is sort of just to distinguish it from those, to say this is the per version of this anonymous function. It's the placeholder. Okay, does that make sense? The other thing is sometimes we don't use the tilde at all, and we always can, right? And so this is an important point. We don't have to use the tilde if we just have a function that we can loop through. Okay, so if there's a function that we're going to loop through a vector, we don't have to use the tilde. We can just pass it that function. If we need to pass additional arguments to that function, we can also pass those through map. Okay, so we could say map double penguins, give me the mean of the column, and then na.rm equals true. Okay, obviously I'm getting NAs for the categorical ones, but then I'm getting the actual values for all the numeric ones, whereas I wouldn't otherwise because they do have missing data. Okay, but this line is exactly the same as down here. So here I'm using tilde, and I'm saying give me the mean of dot x, and then the argument to mean gets passed right within there. Okay, so this might be more clear to you what's going on. And if that's the case, go ahead and just use the tilde always, right? There's no reason not to. It's exactly the same thing. It's just this is a little bit briefer, but if this is more clear, go with that one. All right. One more example. The other thing that's nice about the tilde and dot x syntax is that you can apply more complex functions within there. So this is basically a function wrapping around another function. Okay, so here I have penguins, and I'm saying if else is dot numeric dot x, then give me the mean of dot x. Otherwise, return 0 rather than NA. Okay, and so we get 0, 0, and then we get some means, 0, and then some means. I'm not suggesting this is a good thing to do, but what I am showing you is that you can use, basically we're wrapping if else around this mean. Okay, so we're using dot x sort of in multiple places here. We've got if else using is dot numeric, and then we're doing one thing if it is numeric and a different thing if it's not numeric. Okay, and so this is, again, you could use function call or whatever. You could call it whatever you wanted and insert that wherever the dot x is. That's fine too. But the tilde is just a shortcut syntax that gives you this dot x placeholder for the thing that you're looping through. Okay? Any questions on that? All right, that's all the review we're going to have for loops because I wanted to mostly focus on functions. And then, like I said, if we have time at the end, we'll talk about Shiny a bit. Specifically, I want to talk about publishing a tiny bit, and then we'll just have a challenge, okay? All right, so remember with functions, everything is a function, everything. So 3 plus 5 plus is conducting an operation, so therefore it is a function, right? So plus is like a protected one, so we can wrap it in backticks, and then we can make it look sort of like all other functions in terms of we have a name. In this case, the function is bound to the symbol plus, right? And then we use parentheses and we supply the arguments to that function. 3 and 5, we get 8. Okay, so these two things are the exact same. It's just this is a different kind of function called an infix function. Okay. Most functions are bound to a name, right? So the function mean, we could look at that function and we will see that it is, we can see the body of that function, but we call that function by actually typing mean, right? And that's because that function is bound to the name mean. Anonymous functions are also common, so we saw examples of those earlier when you write function x or whatever and you're using a loop. But you can also, and this is, we didn't spend a lot of time on this because it's not real common, but it is a nice thing too. You can also include a bunch of functions in a list, okay, where each element of the list is a different function. And then you can loop through that list of functions and apply all of those functions to one specific vector, okay? And that can be an efficient way to do things at times. So what we're going to do is we're going to actually write a function. It's too bad I couldn't have just gotten to here before everything failed. So we're going to write a function that takes two arguments, a data frame and the name of a discrete / categorical variable in the data frame, okay? And then the function should return the count of each level in the categorical variable, okay? And for a small added challenge, if you have time, have it optionally return the proportion of each level, okay? So here's an example with Palmer penguins. Here it is for species, where I have the count for each of them. And here it is for species where I'm returning the proportion, okay? So you try first. Go ahead and actually test it out with Palmer penguins and see if you get the same result I did. You can use non-standard, or you can use dplyr if you want, but you'll have to be careful about non-standard evaluation. You also don't have to return a data frame output if you don't want to. you could return just a, whatever, a double if you want instead, an atomic vector. Okay, so I'm going to give you 7 minutes to go ahead and try that. I might actually cut you off like a minute or two early just because we lost time there, but try your best with that. Okay, let's go ahead and move forward. There are lots of different ways that we can do this, of course, but where do we start? As I mentioned before, not with writing a function. I think that's the wrong approach. The first thing that you should do is solve the problem for one example, and then once you have it solved, generalize that code into a function. Okay, so we can use the Palmer Penguins data as an example to solve it first, and then just generalize that into a function. Okay, so there's Palmer Penguins again. There's lots of different ways. I'm going to start with the base method. Okay, so here's one way we could do it. We could first split penguins by the categorical column. Okay, here I'm splitting it by species. Then I can count how many rows are in each split. Okay, because we know only species of a specific level are going to be within that data frame. And so we can say sapply on split, give me the number of rows. And we get 152, 68, and 124. Okay, we could go on from here, but that's basically it. That's the output that we want, right? It's the count, the number for each level. And it's not a data frame output like we originally had, like I showed, but I also said you didn't have to have that, okay? So now we can wrap it in a function. What will the arguments be? Well, I already told you what they would be. They would be the data frame and the column that you want to summarize, right? So we also need to come up with a good name for our function. I'm calling it getCounts. You could call it whatever you want to call it, but ideally it would be something that is like an action verb. Okay, so getCounts is what I'm calling it. And it's going to be a function with the df, the data frame that you're passing it, and then the column that you want the counts for. What will the body be? The body will be just the code that we wrote before, basically. Okay, I am, to be a little safer here, making a few changes. First, this one's fairly significant. I have to actually index the column slightly differently here on my split. So I'm using df double bracket column, and I'm expecting column is going to be a string. Okay, I'm doing it this way because I can't actually use the $ like that within functions. And the reason is because $ is actually a form of non-standard evaluation. Okay, so if you wanted to do that, you would have to do a lot of other complications. But you can get around that by just doing something like this. So this is it's going to give you the column just like the other one, as long as column here is a string saying the column name. Okay, there's other ways you could do it too, right? You could do brackets, empty first indicator, comma, and then string. You might even be able to do it with a single one. I think you could actually. But so now I have my split here, right? And then the second change I'm making is instead of using sapply, because I'm using this function within a function, I'm going to use vapply to be a bit more strict. Okay, so now I'm expecting that the output is going to be integer, where on each iteration it's going to give me one result. Okay, and if it's not that, then I'm going to get an error. Okay, but vapply and sapply, right, are the same thing. Vapply is just more strict. So now we can test it out. Okay, so I say get counts on penguins, and I pass it the column species, and there you go. If I say penguins island, then I get different counts for now the island. Okay, so that's one way to do it. But let's say we wanted to extend this now. So this is the atomic vector output, right? So you can go ahead and just copy this code. And then what I would like you to do is try to extend this now so that it actually has data frame output. Okay, if you did it using dplyr or some other way and you already have data frame output, that's great. But I would still like you to copy this and try to extend this code so that this code has data frame output. Okay, give it a try. Okay, so here's one example. Okay, and again, always multiple ways to do these things. I took the first parts, and now I'm just saving this vapply part into this thing I'm calling counts. Okay, and then from there, I'm using tibble. You could use data frame. The only thing with using data.frame in this case is because counts is also named, the row names will end up as the same thing as what I'm calling var levels here. Okay, which is so var levels is equal to the names of counts, and that could also be the names of split because both of them are going to have the names of the levels, right? And then the count is equal to the counts. That's it. Okay, so we're taking this same code up above here, and now we're just basically wrapping it in a tibble where I'm saying the var levels are equal to the names, and then the counts are equal to the actual counts. Yep, Chris?
If you end up using any tidyverse function like tibble, and like you've mentioned that you just sometimes will call directly tibble instead of loading the whole tidyverse, do you just kind of throw it out and you're fine doing everything tidy in that? Or do you like try to still minimize it if you're doing it in a function?
Yeah. So so if I am writing a function like this and it's maybe for just one script, I won't worry about it whatsoever. And I would actually probably omit the namespacing even and just assume that the tidyverse is loaded. If I'm writing an R package, I would absolutely try to minimize as much as possible. So I would only import the functions from the packages that I'm using. So I would never load all of ggplot, for example. I would only load the layers of the ggplot that I'm using in my functions.
Thanks.
Yep. Okay, so now we can test it again. Get counts penguin species. We get var levels counts. So now it's a little bit nicer output, right? Get counts penguins islands, and we get a little bit nicer output. But let's try to extend this further. Notice the column name here is var levels. Okay, and that's okay, but can we make this more intuitive? So if I say get counts, it says species here because species is what I'm passing it here, right? And get counts on island, can I make it say island here? Okay, does that make sense? So whatever I'm passing here, I want that to be the column name. Okay, 2 minutes, give that a try. Extend it further. All right, so again, multiple ways to do this. This is the way I chose to do it. Okay, so now I have my tibble here, but I'm just storing that in an object which I'm calling D. Okay, then I just say the names of D1, saying give me the first column of that data frame, which is currently var levels, and redefine that to column. Okay, because column is a string that I'm passing to the function, so that should just redefine that name. Okay, the first name, and then I'm returning D rather than the names of D. Okay, so now I can test it out, and it looks like this: get count, species, species, island, island. The counts are good. Questions on that? Okay. Can we replicate this using dplyr? Yes, of course. We just have to use non-standard evaluation. All right. Out of curiosity, did anybody do this originally when I gave you this challenge? Give me like a thumbs up if you did and you were successful. Okay. All right. So we can do it using dplyr. We just have to use non-standard evaluation. So first, let's solve it on a use case, right? So here's penguins, and I would say count species. Great, it works. That's super simple, right? But will this function work? Right now, I just took the exact code I had before, and I'm just swapping out column for species and df for penguins. What do you think? Is that going to work? No, of course not, because that's not going to be able to find column, right? It has no idea where that is. So in this case, it's pretty straightforward. All we have to do is wrap column in the double braces, okay? And then it works. So this is a very minimal amount of code to have the same exact function that we just built with R. So this is obviously less code than the other one. We do have dependencies now, but it's not that big of a deal in this case. All right, and that replicates everything perfectly. So that's great. An alternative that we could do instead of using the double braces is we could pass the dots. Okay, so I mentioned this before, but this is a good example of when I probably would choose to pass the dots. Because what we're going to do here is say function df and then just dot, dot, dot. This is saying any additional arguments you want to pass. Whatever arguments you pass there will come down here to count. And now we don't actually have to apply non-standard evaluation at all. Just pass the dots like that, and then it works. A bonus for this is that because we can pass multiple arguments, we can actually pass multiple columns now, and it will provide the counts. Okay, this is actually basically just replicating this count function, but whatever, that's fine. Okay, conditions. Let's add a condition to our function now. Okay, you can continue on with the base one or the dplyr one. I'm pretty sure I continue on with the dplyr one, but it doesn't matter, whichever one you want to do. It might be base, I can't remember. Whatever. Let's add a condition that optionally reports the proportions in addition to the counts. Okay, what's going to be the first step to do this if I need to do this? I want to add a condition that optionally adds in the proportion. So it's not always going to do it. It's only going to do it sometimes. What's going to be the first step to doing that? Somebody venture a guess. Nobody knows? Nobody has any idea.
If statement.
If statement. That's a good guess. I would say actually the first thing is adding a new argument for that thing. Okay, so we're going to have our function where we're saying add the count or get the counts or whatever, but then we want to add a new argument that says, do you want the proportions also? Okay, so that's what I've done here. I've called that function return proportions, but you can call it whatever you want. Notice that that argument is doing nothing in this case because I haven't changed the body of my function yet. All I've done is added the additional argument. Notice also I've included a default to that argument. Okay, so return proportions is set to false. So when you call this function now, you can override that and set it to true, but you don't have to supply that function on your own because it will just default to false. Okay, so here's the body of the function. Now we do need to include an if block. Okay, and so that block is going to be, what are we going to do if that argument is set to true instead of false? Okay, so in this case, what you could do, and what I would normally probably do, honestly, is just say if return proportions. But there's also these newer arguments. I think they only came out with R4.0, and we're up to 4.1 now, so they're pretty stable. Well, they are stable, but it's just whether or not you want to depend on R4.0. There's this is true and is false. And so this can make your code a little bit more readable as well, because you can say is true, return proportions. So if this thing is true, then do everything in this block. Notice I still haven't defined anything in the block, but I'm saying if this is true, do something in here. Otherwise, just skip past it. Okay, and then I'm going to return counts. Okay, now I'm going to actually include the block, the code within that block that I want it to evaluate if that condition is true. Okay, so here I'm defining the thing called counts, and then if return proportions is true, then I'm going to mutate and create a new column called proportion, which is just going to be the n divided by the sum of n. Okay, and then I'm going to return counts. So this now looks like this. I can say get counts penguin species. Notice I don't have to supply return proportions because it's going to default to false, so I get just the counts. But if I say return proportions equals true, then I will get the proportion in there as well. Questions on that? Okay, now an additional challenge. What I would like you to do is actually, you can just copy this if you'd like. Use this function inside of a new function, okay? That new function, it should add those counts and optionally the proportions to an existing data frame, okay? So you pass it a data frame that has 200 rows, it should return that same data frame with all 200 rows, but just the counts of the levels added in, and optionally the proportions of those levels as well. Does that make sense? Okay, give that a try. This is how I would do it, all right? I'm creating a new function which I'm calling add counts, okay? That's going to take the same arguments that I had before, the data, the column that I want to summarize or get the counts from, and then add proportions equals false, okay? Then I'm going to create a thing in here called counts, an object called counts, where I'm applying the get counts function. Notice because I was using non-standard evaluation before within that function, I now have to do the same thing here. So data column with the double braces, and then add proportions, whether I want to add those proportions or not. Okay, so this whatever this false or true is going to be passed to what in get counts is referred to as return proportions. But in this one, we're saying add proportions. Do you want to add the proportions to the data set? Okay. And then we're just going to left join the data with counts. And that's it. Okay. So we can test it out. I'm passing this to select afterwards, just so that we can actually see the columns because they go off the screen otherwise. But you don't have to do this part. So I'm saying add counts from penguins, add the counts for species, right? And here's species. And here's the N, and I have island in there as well. Here I'm saying add proportions equals true, and you can see we have the proportion now added in as well. Okay? Does that make sense? Questions on that? Okay, now we're going to try to extend that function, or the other function, actually, either one. So you can embed a warning or an error. Okay, you can decide whichever one you want to do. So that if I am calling this function and I say add counts for bill length, right? Bill length is a numeric column, and it's probably not going to make sense to add the counts for every single value of bill length, right? So include a warning or an error message, your choice, if the column that is passed to it is not discrete or categorical, okay? So this is more difficult with dplyr. So I've given you a hint here. You can use dplyr poll to get just the vector back in return, just the atomic vector, so it's not a data frame, okay? So you can play around with that function outside of your function, and then try to embed a check on the column that is passed to it to check if it's discrete or not, okay? And if it is discrete, continue on with the function. If it's not discrete, have it throw a warning or an error, okay? Give that a try. Okay. Here's one way to do it. Again, there are multiple ways, as always. What I'm doing here is the arguments are the same, but the first thing I'm doing is I'm polling just the column, okay? Just the column that I'm going to get the counts for, potentially. So I'm using dplyr poll from the df, give me the column, okay? So this will return just the atomic vector, all right? Now I can say if is.numeric column vector stop blah, blah, blah. Okay, so I'm embedding an error. And so I'm assuming, right, and this, because if we think about the column types, we have logical, well, having counts on a logical makes sense, right? We have character, yep, that makes sense. And then we have two different types of numeric, double and integer, right? So if it's numeric, either of those two types, double or integer, then I'm going to have it stop. If it's either of the other two types, then I'm going to have it continue on. All right. And so a factor is going to return false when I say is.numeric. Okay, even though it is an integer type underneath the hood, it is a factor type, which is not numeric. Okay, so I'm going to stop if it's numeric. Otherwise, I'm going to continue on with the function. So all of this is just like we did before. Okay, all of this is the exact same. So all we're doing here is just pulling the vector, checking if it's numeric. If it is numeric, we're going to return an error. Okay, otherwise we're going to continue on with the function. Make sense? Okay, so now we can test it out. Here I'm saying get counts on penguins, bill length millimeters, and I get an error, numeric column passed, blah, blah, blah. Oh, right. This is what I wanted to say. I'm using get counts here, right? So I'm embedding this error checking in get counts. But now, because add counts uses get counts, this error occurs for either get counts or add counts, right? And so that's nice because now I only have to embed that error in one function and it will sort of propagate to the higher level functions that call that function. Okay. All right. So that's it for the function review. Any sort of big questions or anything that you want to ask about? Okay. I know all this stuff is difficult. Writing functions is not easy, but it is a nice way to really, I mean, once you get comfortable writing functions and looping in particular, if you can get comfortable with both of those things, the number of things you can do just explodes. All right. So I do think it's worth the effort. Obviously, that's what this whole course has been about, basically. Okay, Shiny. We never really talked about publishing before. So I'm going to talk about that for just a few seconds. And then we'll go to the challenge. But for the challenge, I might give you an alternative option. So publishing. Here, this is a link to just a step-by-step publishing guide for Shiny. So I would recommend actually just walking through that when you get to the point where you want to publish a Shiny app. It's pretty nice. It's really, really step by step by step. Okay, so if you just follow all those steps, you should be good. The easiest way to publish a Shiny app is through shinyapps.io. Okay, so shinyapps.io is put together through RStudio. You can have up to like 5 apps published on there for free. And so that's the best way to do it, as long as you don't have like too big of an application, or so if your application gets too large, then you get beyond the free tier, or if it has too much traffic, then you get beyond the free tier. But generally, if you just have like a smallish app and you want to publish it, Shiny Apps is going to be by far the easiest way to do it. Okay, so what you have to do is you have to first go and register for an account there. Okay, so you just give them your name and email and stuff, and then you get an account. Once you get there, then you're going to have to add a token to your account. All right, so there's a little thing that'll say create token. And when you do that, you'll get a token and you'll also get a secret, okay, which is just this long like string of letters and numbers. Okay, then you'll come back to RStudio and you have to register your account from RStudio. Okay, so you'll say the name, and that's equal to your account name. And then you'll have a token, which is the token that you created there, and then the secret that you created there. Okay, and then once you run this code, which is from the RS Connect package, which I think you all should have now, but if not, you just run install.packages RS Connect, then that would register it for you, and you'd be basically good to go. From there, you would write your Shiny app just like normal. And when you get to this preview window, you would have this publish button. Okay, and you would click that. It will bring up another dialog box that would be linked to your account then. And you would say, yep, that's the one I want to push it to. And so then you say, go ahead and publish it there. And what it's going to do at that point then is it's going to look through your Shiny app. It's going to figure out all the packages that you're using. And much like Rend, it's going to like take a snapshot of those. And then it's going to put it up on shinyapps.io. The reason that you have to do it this way instead of just publishing through GitHub Pages or whatever is because Shiny apps are so different. They actually need a server that is going to conduct the computations as people are changing the input, right? So you basically have to have a version of R running online that is listening to the input from your Shiny app, and that so that it can change how the output renders based on the input. Okay, so you have to have a server side to this, which is different from most of the other stuff we've done, which is just static web pages. Okay, so that's it. So what my challenge for you is to use the Palmer Penguins dataset again, but then create a Shiny app for it. Okay, so what I'm gonna say is we have, and then so there's this part and then this part, and that's it. Okay, we have about 10 minutes left of class. So I'm going to give you an option. Either we can just, I'll hang on for 10 minutes, but you can just leave if you want, and you can do this on your own for 10 minutes, or you can just have the time to yourself that you want. Or alternatively, I can live code and just try to do this with you now. So I don't know, give me a thumbs up if you'd like to do this on your own, or some other emoji if you'd like me to live code and you watch me. Okay, looks like live coding is the answer. Okay, so let me get my RStudio going then. And then I will switch my share. Okay. All right, so you can follow along with me if you'd like. It's totally up to you. What I'm going to do is first I'm going to create a new R package, because, or not R package, R project, because I think it's easier to start with that template. Okay, so I'll say new Shiny web application and Penguins example to the desktop. Okay, create that. It's going to switch over. So now we have our app here, and we can run this app just to be sure what it looks like. All right, and it's here, just the same one we've seen a bunch of times. All right, and what we're going to do is we want to create a new app using Palmer Penguins where the X and Y axis are selected by the user. Okay, but we want only numeric variables to be available. Okay, so what I'm going to do is I like to always just kind of do this stuff on the side, and just like functions, then I'm going to figure out how to sort of generalize this. Okay, so I'll go library Palmer Penguins, and then Penguins, I'm going to go ggplot. Oh, I've got to load ggplot though. Library ggplot2, and then Penguins AES. Let's look at Penguins. We're going to do bill length millimeters, bill depth millimeters, plus geom point, and then plus allow the points to be colored by any categorical variable. So I'll say G plus, so I'd say AES color equals species. Okay, so that's basically what I want. Go here. It's not working for some reason. There it is. Okay, so that's basically what I want. All right, but I want these to be able to be swapped out for any numeric variable, right? And then I want this to be swapped out for any of the categorical variables. Okay, so let's sort of bring this stuff over. I'm going to bring just these over first. Library shiny, library Palmer penguins. Okay, let's go here. So we're going to want a slider input for the x-axis. So I'm going to call this x-axis. Probably not slider though. We want select input, right? Because it's going to be a categorical variable. And then again, I always have to do this. Select input. All right. Input ID is, I'm going to say choose the x-axis. Okay. And then for here, we'll say choices are equal to, and then you can actually do this in a sort of nicer way where you can give the vector names and then it'll be nicer. So for example, I could say bill length, and that's going to be equal to bill length mm. Okay, so that's that'll actually show up as bill length instead, but bill length mm is what's going to actually be fed to it. Okay, then I'll copy that and say bill depth, right? And then this will be bill depth mm, and then flipper length and body mass. So flipper length, that's going to be flipper length m. Bring this over. And then finally, we're going to have body mass. And that's going to be equal to body mass g. Okay. And then I'm going to add a second input just like that. But I'm going to say select input y-axis. Okay. And I'm going to say choose the y-axis. And then I'm going to have those exact same choices. Okay. For each of these two, I could add in the selected. So I'll start it out by saying selected equals, let's see, probably bill length mm. Okay, and then here I'll say selected equals bill depth. Okay, so let's just comment this out for now, and we're going to comment all of this out for now and just run this thing to just see what that part of it looks like. Okay, so here it is, bill length, bill depth, right? Flipper length. Okay, so we have two select inputs. Choose the x-axis, choose the y-axis. So that's good. We're getting there. Now, in the server part, we're going to, actually, I'm going to add one more select input here, where I'm going to say color by, okay? And then, oops, and then I'd say color the points by, and then I will choose the categorical variables. So I would say species is equal to species, island is equal to island, and then sex is equal to sex. Okay, so I actually am not, I'm leaving out year here. I'm just not going to include that in my just not going to include that in my app. All right, we could, but I'm just not going to. Okay, now down here, I'm going to say, I'm going to create an output, which I'm going to call output plot. Okay, function, oops, not function. I'm going to say render plot. Okay. And then I'm going to pull basically this ggplot code that I have here. And I'm going to put it here. But here, for the bill length, this is going to come in as a character. So I'm going to have to do bang bang sim. And then I would say input x-axis. Okay. And then same thing here. But now I'll say y-axis. And then same thing here. But now I'll say color by. Okay? Does that make sense? So this is now plot. And then in my main panel, I'm going to output plot as plot output, not put plot. Okay? Does that make sense? Let's see if that works. I think it should, but we'll see. Yes, looks like it does. So build depth and build depth. Flipper length. Cool. Let's switch this to island. Yep, that works. 6. Okay. So that is basically working. There were other challenges from there, but we are now officially out of time. What I do want to show you real quick, though, is if I do run app, notice I have this published thing. Okay, and I've already set mine up, but I actually have multiple accounts. So you can go manage accounts. I think that's another way that you can link your accounts is just by using like a GUI thing like that. But if I say publish, can you see this part? Yeah, okay. So it's going to say publish app.r, and I can publish it. I have occasionally used Shiny apps within publications, so I created an account called Anano for peer review. So then I can actually link these Shiny apps in my paper that is being reviewed anonymously. But then this is my standard one. Give it a title, and then you say publish, and it would just push the whole thing up there. It'll actually just take you to that link when you're done. Okay? All right, so that's it. Next time, we don't have class on Monday, but then on Wednesday, I will do a quick overview of writing sort of a very, very basic intro for package development. Okay?